Let's look at one like 51C, where we're finding the displacement and distance traveled of a particle that's moving along the real number line. So think about moving left or right. And we're given the velocity, and this is the velocity function that I'm going to use. It's very similar to the one in 5C. It's a quadratic function. We're going to go over the interval from 0 to 4 seconds. T is the time in seconds. I think in the problem 51C, it's from 0 to 6. So very similar. So first of all, what is the displacement? Which means, at time 0, we're at one location. Time 4, we're another location. Where are we relative to that initial position? So if I looked at time 0 to the original position function, where am I at on the real number line? And then at time 4 seconds later, where am I at in the real number line? Am I to the left or the right of where I was originally? Now this is the velocity, so I can't just plug into this. That won't give me position. Okay, so the displacement we have learned, right, is simply the integral of the velocity function over that interval, right? The accumulation of velocity will give us the displacement, essentially. Or in terms of this section, right, the integral of the rate of change, and velocity is what the rate of change of position with respect to time. So the integral of the rate of change is the net change, or in this case, we call that the displacement. So we just simply integrate this function. So it's a piece of cake. Antiderivative of 5t squared is 5/3 t cubed. Antiderivative of 11t is 11/2 t squared. Antiderivative of 12 is 12t. We evaluated at 4 and at 0. So I evaluated at 4. Of course, if I evaluate at 0, I just get 0. And then, this gets a little tedious with some of these fractions. You can do everything, by hand, but it does help in some of these. If I just type in, 5 times 4 cubed divided by 3 minus 11 times 4 squared, which I put in as 16. I think I could do that in my head. Divided by 2, guess I could have done that in my head too. Minus 12 times 4, and then use the convert to fraction key, and you can get, that result, negative 88/3. And then if you want to just hit, well, let's do answer. And then you'll get the approximation, negative 29.333. So there it is. Now the negative, what's the indication of that? That means we're to the left of the initial position. So our displacement is about 29.3 feet to the left of our initial position. Okay, so wherever we started, the particle's moving along the real number line. So wherever we started here at time 0, now we might be moving to the right initially, or back and forth, whatever, but eventually at time 4 we're to the left, right, to the left of our initial position at t = 4. We have traveled this far, which is about 29.3 feet. So that's the displacement, but that's not necessarily the distance traveled, because I might just, the path might be not just going from here to here, but I might say, well, let me go this way and then stop and turn and go this way, and then stop and come all the way back. And by time 4, I'm here. So I've traveled a lot further than my actual displacement. So how do we find distance traveled? Well, it's the absolute value of that velocity function integrated over the same interval. Now here we have to rewrite this into the sum of 2 or more integrals without absolute value. You just can't integrate with the absolute value. Okay. So in order to be able to do that, we need to know when the velocity function is positive and when is it negative. Okay. So we know it's a quadratic function here. So I know it's basically since the positive coefficient in front of t squared, or since the coefficient in front of t squared is positive, we know it's a parabola opening upward, right? It's going to be upward opening parabola. I just need to know where the x-intercepts are. So I'm going to do that by factoring this expression to find out what values of t will make it 0. And so, you can factor by trial and error. If you want to use the AC method, A is 5, C is negative 12. It gives me a product of negative 60. So I'm looking for two two factors that multiply the negative 60 but add together to give me b, right, the coefficient of t, which is negative 11, and the answer is negative 15 and 4, right? Multiply gives me negative 60, add them together, negative 11. So I rewrite this as 5t squared minus 15t plus 4t minus 12, and then I factor by grouping. I factor out a 5t here, leaving t minus 3, factor out a 4 here, leaving t minus 3, and that's real important. That common factor gets pulled out, and I'm left with 5t plus 4. So you could do it that way. If you know how to factor by trial and error, it's probably a lot quicker, right? We know it's got to be a t and a 5t to start off with, and then you just have to figure out the right product for negative 12 to get you that inner, right, the outer and inner add together to that that term, negative 11t. Okay, so there's our velocity function factored. So now we know the velocity is 0 when what? Either one of these factors is 0. So when t is 3, or subtracting 4 and dividing by 5, negative 4/5. Now this is outside our time interval because remember the time was from 0 to 4 seconds. So if I'm looking at our parabola, the red graph, this would be the v of t. The red graph is the v of t, right? And at negative 4/5 and at 3 we're 0, right? That's what we were finding at t equal 3 and negative 4/5. We're integrating from 0 to 4, and so we want the absolute values. What's going to happen from 0 to 3? Our velocity function is right below the x-axis. I want the absolute value is going to look like this, right? So I need to basically do a reflection about the x-axis. And how do I do that? I just multiply by negative 1, right? So these negative values now become positive. From 3 to 4, we don't have to do anything. And so going back to our original integral, right? Here's our velocity function again. So I'm going to integrate from 0 to 3, but I need to multiply by negative 1 to flip it up, right? Because that piece right there has to be positive. Flip that up, right? So negative 5t squared plus 11t plus 12. Notice I distribute that negative through and change the sign of everything. And then from 3 to 4, though, it's the same, right? From 3 to 4, there's no difference. We don't have to do anything. It's absolute value of a positive number is just a positive number. So we just integrate that function. And now, so I've got the antiderivative of this thing is here, and I go from 3 to 0. So I plug in 3. Of course, I plug in 0 to that, I get 0. And then I add this integral here, right? From 3 to 4. Sorry, I'm off the screen there. From 3 to 4, right? So my antiderivative is pretty easy to find here. And I evaluate it at 4. And then I evaluate it at 3. In fact, this evaluation at 4 is the same evaluation at 4 that we had previously, which gave us negative 88/3, by the way. That's this part here. But I'm going to subtract what this evaluates to negative 81/2, and be careful. So a negative minus a negative becomes a negative plus, right, that 81/2. And negative 88/3 plus 81/2 is 67/6, right? So, and very important though, it's positive. It has to be positive for this integral. This integral evaluates to 67/6. It's positive. This integral also evaluates to a positive number, right? If I plug in 3 here, I get 40.5 or 81/2. And you can do these as decimal. I mean, this, of course, it's better to round at the very end here. But 81/2 plus 61/6 is 155/3 or 51.67 about. So you can use your calculator to do the adding of these fractions, convert to fraction key like I showed you. But there is our result. So the total distance traveled is 51.67 feet. So notice originally, the displacement was 29.3 feet to the left, but we actually traveled 51.67 seconds. And you can see right away from the velocity that initially our velocity is negative, which means we're actually moving to the left. So initially we're moving to the left. So we must have passed, right, this location. But then t equal 3, we turn around and come back and we get to 4. So we travel a total of, again, 51.67 feet. That would be our distance traveled as opposed to our displacement. So I hope that clarifies things. The hardest thing really is, being able to find, how to rewrite this absolute value integral, right? After you factor and determine if you can factor, how to split that up into two or more integrals. And the negative, the parts that are below the x-axis, we just multiply by a -1 to make that positive. And then it's just, sometimes in this case, rather tedious evaluations, but that is the idea. I hope this makes sense and helps with this problem.